Hi, my name is Sri Lakshmi Raghav and I'm a junior at Little Rock Central High School. My research was an assessment of a coconut graphene oxide manganese catalyst on microplastic degradation. Microplastics are plastic debris smaller than 5 millimeters in size that are left behind from plastic pollution. They are found in oceans and aquatic systems as well as cosmetics and clothing and pose a threat to human health and marine life. They can be separated into two different categories, primary and secondary. Primary microplastics come from industries and sewage and are put directly into the environment. Secondary microplastics come from larger pieces of plastic in the environment which are broken down into smaller pieces. These substances have created such a significant problem that they are now recognized as contaminants. Many efforts have taken place in order to solve this problem, such as ocean cleanups and government regulations, but the issue still persists. Proxymonosulfate has been used in the past as a way to help degrade contaminants such as these microplastics. The thermal activation of proxymonosulfate releases sulfate radicals, which have been proven to be capable of degrading contaminants. Catalysts can be used to enhance this process in order to more effectively degrade microplastics. In my project, I created a coconut graphene oxide manganese catalyst for this purpose. Coconut shells contain large amounts of carbon which can be made into graphene oxide. Combining this with manganese helps prevent leaching of the catalyst into water. Coconut shells were burned to obtain coconut charcoal, which I put in a tube furnace to create coconut graphene oxide. I synthesized the graphene oxide with manganese chloride to form the catalyst through ultrasonication and refluxing. I got my microplastics from facial cleanser as that was the source that was more readily available to me. I diluted the facial cleanser in DI water and filtered and washed the microplastics out. For the microplastic degradation, I combined the catalyst, microplastics, and proxymonosulfate in DI water and placed the samples in a constant temperature water bath for various amounts of time. In my results, I found that the longer the time, the higher percent of microplastics degraded, so the highest percent degraded was 16.5% at 5 hours. I also performed Fourier transform infrared spectroscopy and X-ray diffraction on the coconut charcoal and the coconut graphene oxide in the catalyst to help confirm their formation. In the future, I would like to perform scanning electron microscopy imaging on the microplastics and elemental analysis on the coconut charcoal, coconut graphene oxide, and the catalyst to help further confirm their formation and composition. I would also like to test my catalyst in changes in pH, temperature, and catalyst concentration to find the optimum conditions that it will work in. This catalyst can potentially be used as a replacement for other catalysts to help further degrade microplastics.